Yeah, we hear from several speakers that the speeds are increasing. There are reports saying that 1 gig is now the so-called de facto standard. And of course, when we come to installing this into an MDU building, then we have always the different type of hurdles that you have to pull in new cabling and access to the building and so on. And if you can use the property networks, which can be a telephone wire or a coax wire, then maybe this could simplify your fiber deployment and also increase the acceptance for new services. And we can see that the next step seems to be multi-gigabit. Google is already offering 2 gig. AT&T announced in end of January that they will have 2 gig and 5 gig service. GCI will going to 2 gig. Fios is with 2 gig services. Zigbee Fiber 5 and Altis also announced that. So we are moving towards multi-gigabit service. And of course, question is raised, can I use the existing property networks? And which of the property networks should it be coax wiring, or can we reuse the twisted pair? If you go to these 2 existing property networks which are available, coax cable is today used by the cable operators. But there are trends now that more and more people are cutting off the cord and the cables are there unused. And if you look on the age of the building wires, coax cables has been refurbished with the time. They have gone from 470 megahertz technology up to 2 gigahertz technology. Twisted pair hasn't done that because it don't have the shielding capabilities. Both these technologies are available at an entry point in the building, and these are also reaching the home location with a plus from the coax cable, because it goes typically to by the TV set. And we have heard that next generation of 8K TV consumes 50 to 100 meg. So it's important to have that very close to the technology which is consuming most broadband. And always it comes to question of attenuation. How long can I go with these cables? And here also coax has a strength. And support for multi-gigabit. Yes, we have multi-gigabit in the coax technology already today. It's proven by the cable operators. They are offering multi-gig services, while the twisted pair is have a limitation, which is around 180 megahertz. So, and that will not provide more than, in the best case, in small buildings, 1 gig. And if there is a 10 gig roadmap, yes, coax have that. What is this magic coax? It is, I will do a recap of that. It is a cable which has a twisted, it's a cable with a braid and folio, which is isolating, and then you have an inner conductor. And the typical spectrum for coax cables is from 5 to 2150 megahertz. The 2150 megahertz is used for satellite communication. And there are 2 different types of called RG59 and RG6. And the attenuation then, I mean, for RG59, we have about 26 dB on 100 meter. And on the RG6, it's 22 dB on 100 meter when you measure at 1 gigahertz. So this limits the length. You can't go too far. So typical max lengths are 200 meters. And then comes the next question, what is the type of topology? And there are 2 principal topologies. It's one where you go point to point. You have an entry point. In this case, the 4-way splitter, where it goes a cable from that location up to each of the apartments. The other way is to use a type of called tap technology, where you have one wiring where you tap off that. And of course, the benefit of using point-to-point gives that you can have availability of the full cable, while in the tap technology you have to share the capacity. And this makes some differences. This star topology, that if it's entered from the basement, wall cabinet or outer cabinet, can enable multi-gigabit. That means you can use the full spectrum, which is up to 2150 megahertz, while the tap technology is a shared medium, and that enables only 1 gigabit. If you look what is the type of cables, where are they available? I mean, in the US, about 90% of all the cabling is start topology, that means a point-to-point connection. While in Europe, in some countries, it's also 80-90% like Germany. But there are also countries where you have this type of topology, which means it's a shared medium. And in that case, you can only deliver 1 gig. So, and we look on the trends, what's happening out. I mean, something called cutting the cord trends. In major cable providers, collectively have lost about 6 million TV subscribers each year between 2019 and 2021. I mean, people are leaving the pay TV world and going over to watch when you want type of world. And also US cable and satellites lost from 2012, 25 million subscribers. So the streaming TV are increasing very quickly, and the TV service need, as we have heard earlier, high speed broadband connection. And on the right side, we have an example. This is taken from a Texas installation where Dish did leave the place, and then the cables were open and to be used for new broadband services. And there are a number of technologies, and one of the technologies which can provide this multi-gigabit speed is MOCA Access. And I will go quickly through this. It's a bridge. It can provide a max speed of 2.5 gig. And if you extend the bonding, you can come up to 5 gig. That means that it meets the requirements which several operators are today asking for a long-term investment. And it can be configurable downstream, upstream ratio. That means you can have symmetrical speed, and it's using TDMA, and it supports per cable up to 256 multicast addresses and shaping and 4 QS. And average latency is less than 3 milliseconds, and that's meeting the requirements we have on I mean, gaming and such type of services. And in the PHY side, it's using of the spectrum up to 2150. It's using from 400 to 1675 megahertz. And when you have extending bonding, then you are using dual MOCA access bands. And as I mentioned, it's supporting both the point-to-point and point-to-multipoint technology. Packet errors are very low, minus 10 up to -6 and 10 up to -8. And it is also, the link is encrypted, so neighbor can't look if it's in a point-to-multipoint topology, then they can't hear or look what you're doing. And then there is 3 type of power controls. So MOCA access technology has been designed to meet these fiber access extension requirements, and that's also the reason why we have been pushing the TR419 working within BBF. And we look on what is the ratio between bitrate and signal noise ratio. MOCA has been designed to be very robust. That means that if you have a signal noise ratio which is from 40 dB and above, you can have a speed of the coax link of 3.2 gigabit. And if somebody is adding, for example, an extension cable, which maybe are not the best quality, you still have this about 2.5 gig. So it is very robust from that point of view. So you don't get complaints when, for example, you're adding bad cabling. There is a buffer in the technology. And coming to the bundling side, today MOCA is built on 5 physical interfaces over the coax. It's a 5, 1, 2, 3, 4, and 5, and these are 5 independent radio channels. And this provides the 2.5 gigabit MAC rate. So it's the first step in the multi-gigabit world. If you want to increase the speed, then you add 5 additional channels, 5, 6, 7, 8, 9, and 10, and that provides the 5 gigabit MAC rate. So with this MOCA access technology, you can ensure that the investments you do in fiber, that will be able to provide services for a rather long time ahead without forced to put fiber into the building. And the way it is done is that you have the channel 1 to channel 5 in the spectrum from 400 to 900 megahertz, and then you have adding the 5 channels there from 1 gig up to 1500. 1 gig to 1.5 gigahertz. So it's adding more channels, which adds more capacity. And the way of deploying this, the TR419 defined a number of deployment scenarios. One is the left outer box, which is an outdoor cabinet. Then you have a wall cabinet. You can install the DPU in the basement or in the loft. So there's a number of places where you can do in single-family home the deployment. If you use a multi-dwelling unit, you have the outdoor cabinet, and then you have the wall cabinet, and in the building you install the DPU either in the basement or in the loft, depending on where the coax network is starting, or you can even do it floor by floor in bigger MDU buildings. So there is a very big flexibility how you can deploy this node, which is extending the fiber connectivity into the subscriber. And how would this look like in the type of equipment? It is using an ONU, and either you have one MOCA network controller unit and you have a splitter, and this is the 1 gig service deployment, so you can have up to 31 CPEs on one MOCA NC. The other model is that you use an ONU and you have a MOCA channel to each of the customers, and this is now getting more and more attraction because that's solving both the gigabit speed service. You can have the multi-gigabit speed at 2 gig, and you can have the 5 gig service, and that means an investment in this technology gives a long life length for the service provisioning up to 5 gig to each subscriber, and keeping in mind that this is a symmetrical service. So the question, can coax be used for multi-gigabit fiber extension? Yes, it can absolutely be done that. And this is proven by a number of ongoing evaluations and also live deployments in the US and Europe. So coax is living up again, and it is providing those high-speed services. And it's not cable operators hardly using that, it is fiber operators and telecom operators mainly. So thank you, that was my part, and I leave over to Pierre.